Hello, this is Raphael Murphy presenting for Group 5. Our presentation is on the next generation of nuclear reactors on the new class of aircraft carriers. My group mate is Eric Pate. There are some key questions we would like to address in this presentation. How has nuclear power on carriers evolved? When was the first nuclear-powered carrier built? Where is the future of nuclear power on carriers going? What does nuclear power allow on board a vessel that other power plants cannot achieve? We hope to answer all these questions in our slideshow. The first nuclear-powered aircraft carrier was the USS Enterprise. The first surface vessel to carry this type of power plant, it had 8 reactors on board, the only carrier to have more than 2 nuclear reactors on board. It used A2W Westinghouse nuclear reactors, a PWR type reactor. On future models, each reactor drove one propeller shaft and used light water as both the coolant and moderator. It used hafnium control rods as well. Because the reactors could produce over 600 psi of steam, they were also used to power steam catapults, lift operations, and other mechanical operations. She was the only ship of her class. The Nimitz-class supercarrier is probably the most recognizable nuclear carrier in history. There were 10 ships built in total, the last one being the USS George H.W. Bush in 2006. The 2-reactor design of the Nimitz allowed for smaller reactor spaces and made the system less complex as a whole. This means that she could perform her missions better, carrying 90% more aviation fuel and 50% more munitions. The reactors on board the supercarriers are 2 A4W naval PWR reactors. Each reactor drives 2 propellers with a combined total of 200 megawatts of power between both reactors. About 10 megawatts are used for the steam catapults and electricity for the ship, leaving 190 megawatts to power those propeller shafts. Because there are only 2 reactors, the Nimitz and her counterparts only require refueling after 20 years, compared to the relatively short 10 years for the Enterprise. The new Gerald Ford class supercarriers will consist of 3 ships, each designated to serve 90 years. Their reactors are even more efficient, with a 45-year refueling cycle. There will be a new system implemented, from automations, which reduces crew size to 600, to electric elevators and utilities, and electric weapon systems. They will be powered by 2 PWR type A1B reactors, the first reactors designed by Bechtel Marine Propulsion. These new reactors will produce over 3 times the power of the older A4W for a total of 600 megawatts per carrier. These new reactors will utilize a large amount of automation, reducing operating crew by 66%. New water pump systems are also going to be used, reducing maintenance and the power necessary to drive those pumps. These systems will feature 50% fewer valves, piping, pumps, condensers, etc. than the A4W reactors. The reactors were made with the intention of making them forward compatible, allowing future components to be easily installed into them. Because of this feature, only half of the reactor's power will be used at launch. Some of this extra power will be used by the Navy's new aircraft launching catapult system called EMALS, which stands for Electromagnetic Aircraft Launch System. This will replace the old steam catapults. EMALS has several advantages to the old steam catapults, which include a smaller size and a more reliable system. It is also easier to fine-tune prior to launch. This requires large amounts of electricity, however, which could not have been met by the old Nimitz-class carriers. LAWS, or laser weapon systems, is another weapon system which requires massive amounts of power that only the new reactors can provide. LAWS requires 10 megawatts per shot, which is the total leftover power from the A4W reactors used on the Nimitz. It is capable of shooting down incoming enemy aircraft and missiles. The last new system which will be mounted in the foreseeable future is the railgun. This system again requires large amounts of electricity to run. It launches projectiles at over Mach 7 and has over 100 miles of range. In summary, nuclear technology is what allows all these new advancements in the Navy's new aircraft carriers to be placed on board. Previous iterations of naval nuclear power weren't able to host such an array of power-hungry machines, something that the A1B reactors will have no problem with.